Hello friends, welcome back. Hearty welcome to you. Let us look at this very interesting problem related to coordinate geometry, straight lines. In triangle ABC, coordinates of vertex A is 0, 0. If equations of angular bisectors of B and C are x plus 3y equal to 4 and 2x plus y equal to 3, then find the inradius. So we have been given a triangle ABC. Coordinates of vertex A are 0, 0. We have been given two angular bisectors BD and another is CE. We have to find out the inradius. We know that inradius is radius of circle in center, and in center is actually the point of intersection of angular bisectors. So looking at the diagram, we know that this particular point, which is a point of intersection of angular bisectors BC and ED, is our I in center. Now how to find out the inradius? If you can easily find out the in center, because we know the equations of BD and CE which are given to us, so we can easily do that. We can do BDCE linear equation in two variables, elimination method, we get your I back. Now once we get the I, how to get the inradius? To get the inradius, we should know one of these sides equation. Then I can find out the distance from the point to the line or perpendicular distance, so that we can get the inradius of the circle. Now how to get the equation of one side? For that, what we will do, we will try to take image of A on the angular bisector first time BD, and next time image of A or reflection of A on angular bisector CE. Now those two will be points on BC. How it is, I'll explain you once we are done with the problem. Once we solve that, I'll explain you why the image of A of the angular bisector will be a point on the opposite side. That we will see afterwards, but first we will write down the steps. We'll try to solve the problem, then I'll explain you why are we using that. So let's go back and write down. So what is our approach? We will write down the step 1. What we have to do is find coordinates of I. So we'll write down in simple way, find I coordinates. Okay, that's the step 1. Step 2, what I have to do is I have to find 2 points on, I have to find out 2 points on BC. That's what I have to do. Once I find out the 2 points on BC, I can find the equation of BC. I have to find out equation of BC. Once I find out the equation of BC, I can easily find out inradius. I can find out inradius. So these are the steps we have to do. First we have to find out I, then we have to find out 2 points on BC. For finding out 2 points on BC, what we do is 2 steps we do. First we do find image of A on angular bisector BD one time. Second time we do A on CE, because 2 angular bisectors we have. One time we do that on image of A on BD, another time we do image of A on CE. So this is our steps or algorithm what we follow to solve this. So first we have to find out what is I. We can easily do that. We will finish that step first. Then we will go to find 2 points on BC. For that we will find out image of A on BD and image of A on CE. Then we will find out equation of BC. Once we know equation of BC, we can find out the inradius because it's perpendicular distance. So let's go ahead and do one by one. First let's go to the point 1. We have to find out what is point I. Let's go to find out what is point I. Now point I is nothing but point of intersection of BD and CE. So we know we can directly write down BD equation is x plus 3y equal to 4, and CE equation is given by 2x plus y equal to 3. You can solve this by any method, whatever method you want. You can elimination method, substitution method, any method. We'll just take the simple method. So I will do elimination method. I will take the first one, multiply with 2, so that I get 2x plus 6y equal to 8. And the second equation is 2x plus y equal to 3. We'll finish it fast. We do subtraction. 2x cancels. We get 5y equal to 5. That means y equal to 1. Once I get y equal to 1, I can substitute in x plus 3y equal to 4. That gives me x plus 3 into 1, 3 equal to 4. That means x equal to 1. So we found out that coordinates of I are 1 comma 1. So we can go back and write down that is 1 comma 1. So we found out the coordinates of 1. So step 1 is done. Let's move to the step 2. To move forward to the next step, find 2 points on BC. We need to find out image of A on BD, image of A on BD. This is BD. We want image of A on BD, that is point G, and image of A on angular bisector CE, that is point F. Now how to find out the image? If you directly know the formula, you can substitute the formula. Otherwise I directly go by the process. What I do to find out the image is, first we know the equation of BD. So can we get the equation of the perpendicular to that? Because image is nothing but the reflection of the point or whatever the line we are getting, AG, will be perpendicular to BD. Always the mirror or the BD will be perpendicular to AG. So what we will do first, now we get the equation of AG, then we solve BD and AG, we get the point Y. We know Y is midpoint of A and G because it's a image. Image means they are at the equal distance from Y. AY equal to YG. So we will find out coordinates of G. Same thing we will do with other angular bisector CE also. So let's go ahead and do that. Equation of BD is given by x plus 3y equal to 4. So BD perpendicular is AG, and equation of AG will be given by, perpendicular line is given by 3x minus y plus k equal to 0. I hope you are okay with that. And AG should pass through 0 comma 0. That tells me by substituting 3 into 0 minus 0 plus k equal to 0. That means equation of AG is equal to 3x minus y equal to 0. Equation of AG is 3x minus y equal to 0, or can I say y equal to 3x. Now let's take this and substitute in the first equation. I will have x plus 3 into 3x is equal to 4. Can I say 10x equal to 4, or x equal to 4 by 10, which is equal to 2 by 5. If x equal to 2 by 5, that means y equal to 3x, which is equal to 3 into 2 by 5, that's equal to 6 by 5. Now these are coordinates of y. These are coordinates of y, which is nothing but intersection of BD and AG. But we know that y is the midpoint of AG. So just now we found out the coordinates of y. We know a is 0 comma 0, y is 2 by 5 comma 6 by 5. So what will be the coordinates of g? For that we can use the midpoint formula. X1 plus x2 by 2 equal to 2 by 5, y1 plus y2 by 2 equal to 6 by 5. So that gives me the coordinates of g as 4 by 5 comma 12 by 5. So we can go back to G and write down there. G coordinates are 4 by 5 comma 12 by 5. Now similar way, let's try to find out the coordinates of F. Once we get the F, we can get the BC equation. To find out image of A on DE, CE actually, image of A on CE. First we know the equation of CE. CE equation is given by 2x plus y equal to 3. So the line which is perpendicular to CE, that is nothing but AF. AF is perpendicular to CE. That means AF equation will be of the form of x minus 2y plus k equal to 0. But we are passing through 0 comma 0. That means if you substitute 0 comma 0, you get k equal to 0. That means the equation is x minus 2y equal to 0. So equation of AF is x minus 2y equal to 0. Equation of CE is 2x plus y equal to 3. But from the first equation, we know x equal to 2y. So can I write down 2 into 2y plus y equal to 3? Or can I say 5y equal to 3 or y equal to 3 by 5? If y equal to 3 by 5, x equal to 2 times of y, that's equal to 6 by 5. We know a equal to 0 comma 0. Just now we found out that x, which is midpoint of AF, is 6 by 5 comma 3 by 5. So what will be f? By again midpoint formula, we get f equal to 0 plus question mark divided by 2 is 6 by 5. That means question mark is 12 by 5. Similarly, 0 plus y divided by 2 is 3 by 5. Y equal to 6 by 5. So we can go back and write down the coordinates of f as 12 by 5 comma 6 by 5. So with that, we are done with step number 2. Let's move to step number 3 so that we can finish it fast. Equation of BC, because we know 2 points now. 12 by 5 comma 6 by 5 is 1 point. 4 by 5 comma 12 by 5 is another point. We should be able to find out equation of BC, then we can find out in radius very quickly. Equation of BC, we have 2 points, so we can use y minus y1, y minus 12 by 5 is equal to m, slope is nothing but y2 minus y1 divided by x2 minus x1, that's m, into x minus x1, that is x minus 4 by 5. So let's simplify this. We get y minus 12 by 5 equal to 6 by 5 by minus 8 by 5, that is minus 3 by 4 into x minus 4 by 5. Let's multiply with 5, or let's multiply with 5. We get 5y minus 12 equal to minus 3 by 4 into 5x minus 4. Let's simplify that. We will have 20y minus 48 equal to minus 15x plus 12, or can I say 15x plus 20y minus 60 equal to 0, or divide by 5, you get 3x plus 4y minus 12 equal to 0, because 5 3s are 15, 5 4s are 20, 5 12s are 60. So we got the equation of BC now. Only the thing we need to get now is in radius. So now we know the equation of BC. We found it out. We have the equation of BC. We know I. So we draw that separately. We know the formula for perpendicular distance. So directly we can go ahead and write down IR equal to, the equation is 3x plus 4y minus 12 equal to 0. 3x plus 4y minus 12 equal to 0. Substitute 3 into 1 plus 4 into 1, because IR is 1 comma 1, minus 12 divided by square root of 3 square plus 4 square, which is equal to 5 by 5, and that's equal to 1. So the in radius of this particular circle is 1. Now since we have finished the problem, now let's understand why actually the image of A on the angular bisector will be a point on the other side BC. With that, we'll wrap up this particular problem. Now let's consider any one of the angular bisector. Let us say suppose I have taken BD. Now what's the triangle we have created when we have drawn when we have found out the image of A on G, image of A on angular bisector BD, image of A which is nothing but equal to G. So what is this triangle we are talking about? ABG triangle. So let's try to understand how we can look at this. We have a triangle A and B and G. We have angular bisector from B coming. That means these two angles are equal. We know that. And what we have drawn is a perpendicular. That means we know that these two are at 90 degrees. Now you can see that if this point is Y, right? Let's put that point. This point is Y. So what we have drawn is just simply this ABG again. And you can see that these two triangles ABY and BGY are congruent to each other. ABY, BGY are congruent to each other because we have ASA congruency. We have two angles which are equal in both of them and we have 90 degrees. We have common side. So ASA congruency by CPCT we get that AY is equal to YZ. AY equal to YZ. We get AY equal to YZ. That means if you find AY equal to YZ means what's the meaning of that? Y is midpoint of AZ. And also you know that BY is perpendicular to AG. BY is perpendicular to AG. That means BY is the mirror. BY or the angular bisector is the mirror and the image is nothing but the point on BC. So with this logic we can understand that why we have gone ahead with finding out the image of A. We went with the image of A on the angular bisectors because we know that there is a congruency existing, and when we take a image it will be exactly a point on the opposite side. The proof is here what we have gone through. Now we recap this again. We have ABG triangle. We have drawn the perpendicular AG to BD or BY. Now we know that these two triangles are congruent to each other by ASA congruency. By CPCT, AY equal to YZ. AY equal to YZ, and we also know that BY is perpendicular to AY. That means BY is the mirror and G is reflection or image of A. That is why when we want to find out the equation of BC, we have leveraged that property and we have taken 2 points G and F. That's one very interesting example which I thought of sharing with you because I haven't seen this in any of the general prescribed textbooks. It was shared by one of the students, thanks to him. So I was able to learn that. So I thought I will certainly share that with you so that you'll go through it once. Thanks for your time and support. Bye for now.